Hi, so what if we would like to insert some item at the end of the list? I'm going to have the insert end method with the self and the data we would like to insert. And basically we just have to iterate through the list. So first we have to increment, so self.size is equal to the self.size plus 1. So we increment the size. We create a new node is equal to a node with the data. This is how we instantiate a class. And we have a reference to the actual node. We initialize it to be the head, so the first node in the linked list. And while this actual node dot next node is not equal to null, so is not a null or a none, then we basically hop to this actual node is equal to the actual node dot next node. Okay, so basically we would like to find the end of the linked list. Why? Because if you may recall, if we would like to insert an item at the end of the list, we start at the head or the root or the first node in the linked list, and we have to iterate through all the items until we bump into a null or a none. If the next node of a node is pointing to a none, we know that this is the last item, so we set it to be the last item. So for example, if we would like to insert 25, then we try to find the last item of the linked list. This then is pointing to a null or a none, so this is the last item, so we tell this node to point to the 25. This is how we insert an item at the end of the linked list. Okay, so this is how we iterate through the list and find the last one. And basically, we just have to update that actual node dot next node is equal to the new node. Okay, so this is how we insert that given new node to its position. And basically, that's all about it. What's the difference? The running time, basically, it has ordo n time complexity, while inserting at the start has ordo 1 constant time complexity. Basically, this is why linked lists have came to be. This is why we like linked lists, because inserting item at the beginning or the start has ordo 1 constant time complexity. Inserting at the end is not that efficient. Okay, and I'm going to implement the traverse list method. It's going to get a self. Basically, we have to store a reference to the first node, so the head. And while the actual node is not a null or a none, we just have to print out that print %d, and we know that we are going to print out the actual node dot data. And we know for certain that it's going to be an integer, so that's why we are going to use this %d. And then the actual node is equal to the actual node dot next node. Okay, so this is how we traverse the list. Actual node, and we store a reference to the actual node, and until this actual node is not a none, we keep iterating and getting the next item possible. Okay, so that's all about the insertion and the traverse method. What's very important, that inserting at the beginning is very fast. Inserting at the end is not that fast. It has linear time complexity because first we have to find the end of the list, so we have to scan through the whole linked list. Thanks for watching.